Good day, math learners. For this video, I am going to discuss on the t-distribution. When we say t-distribution, it is just like the normal distribution, which is also a bell-shaped distribution, and it is symmetric. Consider the illustration at the right side. The broken line curve, which is this one, is the standard normal distribution or the z distribution, and the solid line curve, which is this one, is the t distribution. This t distribution can be thought of the cousin of the normal distribution. It is bell-shaped and the area under it is equal to 1. However, t distributions are flatter and the area of the tails are wider than the normal distribution. The shape of the t-distribution depends on the sample size. As the sample size gets larger, the t-distribution gets closer to a standard normal distribution. Statistical analysis on some studies which cannot be done using the z-distribution can be done with the use of the t-distribution. The t-distribution is used with small number of samples taken from the population that are approximately normal, that is, n, or the sample size is less than 30, while the z-distribution is used for much larger samples, that is, n, or the sample size is greater than or equal to 30. So here is the t-statistic formula. Again, when we say statistic, it is a measurement that describes a sample. So this formula is intended for samples. So we have t is equal to x bar minus mu over s divided by square root of n, where x bar is the sample mean, mu is the population mean, s is the sample standard deviation, and n is the sample size. So this is the t-table. This will be our guide to identify the critical values of the area of the tails in the t-distribution. The first column is considered as the degrees of freedom. They are an integral part of inferential statistical analysis, which estimate or make inferences about population parameters based on the sample data. The second, the third, the fourth, the fifth, and the sixth columns, they are the critical values of the t-distribution. This row or this heading is the set of values of the area in one tail. And this row or this heading, please do not be confused on this. This is the set of values of the area of the two tails of the t-distribution, or we consider this as the level of significance. So why do we have 0.20 here? Because when you add 0.1 by itself, then it will become 0.20 or 0.2. If you add 0.05 by itself, then the answer is 0.10 and so on. Or if you add the area of one tail by itself, then the result would be the area of the two tails. Okay, so this is the continuation of the table. To find a value in the table of t critical values, the sample size must be converted into degrees of freedom. So we have this solution to get the value of the degrees of freedom, which is df is equal to n minus 1. For example, find the degrees of freedom of the following sample size. For n is equal to 12, we will just substitute the formula for the degrees of freedom, which is n minus 1. So we have 12 minus 1, and the answer is equal to 11. For n is equal to 14, we have 14 minus 1, and it is equal to 13. For n is equal to 16, we have 16 minus 1, and the answer is equal to 15. For n is equal to 24, we have 24 minus 1, and the answer is equal to 23. And for n is equal to 10, we have the solution 10 minus 1, and the answer is equal to 9. For example number 2, a sample of n is equal to 20 is a simple random sample selected from a normally distributed population. Find the value of t such that the shaded area to the left of t is 0.05. So, this is the illustration of the t distribution based on the given problem. So, here are the solutions. First is to find the degrees of freedom. So we have this formula, df is equal to n minus 1, and substitute n with 20, then minus 1, and it is equal to 19. Then represent what is asked in a curve. Since the distribution is symmetric about 0, then the area to the right of 0 is equal to the area to the left of 0. Using the table, use 0.05 in area in one tail and find its intersection with the degrees of freedom, which is 19. So we have 0.05 here and 19. Get their intersections and we got 1.729. Again, since we are looking for critical value of the area shaded to the left of t is equal to 0.05, so t sub negative 0.05 is equal to 1.729. Don't be confused on this t sub negative 0.05. It is negative because this area is located at the left. Another example. Suppose a sample size of 12 is taken from a normal distribution. Find the critical sample size of 12 is taken from a normal distribution. Find the critical value of t sub alpha over 2 at 95% confidence level. So this is the illustration of the t distribution based on the given problem. So here are the solutions. First is to find the degrees of freedom. So we have this formula, df is equal to n minus 1. Substitute n with 12, then minus 1, and the answer is 11. Second, the confidence level is at 95%. So the value of the alpha or the level of significance is 0.05 because the solution is 100% minus 95% is equal to 5% or 0.05 as the value of the level of significance. 100% here because this is the total area of the curve, and 95% here because this is the confidence level. So you might be asking me, what makes this area to the left is equal to 0.025 and to the right of t, which is shaded, 0.025. Now, here is the reason. If we are going to substitute the value of alpha in this notation, that is t sub 0.05 divided by 2, then it is equal to t sub 0.025. And we are not yet done because we have to look for the critical value of t sub 0.025. So we are going to look for the intersection of the area in one tail, which is 0.025, and the value of the degrees of freedom, which is 11 in our t distribution. And their intersection is 2.201. Again, the critical value of t sub 0.025 is equal to 2.201. Another example, find the critical value of t sub alpha over 2 at 95% confidence level and degrees of freedom of 10. Here are the solutions. The value of alpha, or the level of significance, is equal to 0.05 because the confidence level is at 95%. So, the t sub alpha over 2 is equal to t sub 0.05 over 2. Simplify them further and it is equal to t sub 0.025. Next is to find the intersection of 0.025, which is the area in one tail, and the value of degrees of freedom, which is 10, and that is 2.228. Again, the critical value of t sub 0.025 is equal to 2.228. Another example, find the critical value of t sub alpha over 2 at 90% confidence level and degrees of freedom of 5. Here are the solutions. The value of alpha is equal to 0.10 because the confidence level is at 90%. So the t sub alpha over 2 is equal to t sub 0.10 over 2. Simplify this one and it is equal to t sub 0.05. Next is to find the intersection of 0.05, which is the area in one tail, and the value of degrees of freedom, which is 5. And that is 2.015. Again, the critical value of t sub 0.05 is equal to 2.015. So this time, we will be identifying percentiles using the t distribution table. So percentiles can be identified using the t table. When we say percentile here, it refers to the probability or the area of a certain region in a t distribution. For the problem number 1, what is the area of the shaded region in the right if the area in the shaded region to the left of negative t is 0.10? Since on the graph we see that the shaded region is identified by negative t and t here, and that the curve is symmetric, then we can deduce that the shaded region in the left and right are equal. So the area of the shaded region to the right of t is also 0.10. Problem number 2. What is the area to the left of t? We note that the total area under the curve is equal to 1. Since this is the line or the indicator for t, the area to the right of t is equal to 0.10. So the solution to get the area to the left of t, which is this one, is 1 minus 0.10, and it is equal to 0.90 or 90% as the area to the left of t. For the problem number 3, what does T represent? T represents the 90th percentile or T sub 0.90. For the problem number 4, what is the critical value of T? Based on the illustration, we have T sub 0.10 because this is the area in one tail shaded to the right, and the degrees of freedom, which is equal to 11. So next is to identify their intersection using the T table. Again, locate 0.10 or 0.1 as area in one tail and 11 for the DF. So we come up 1.363 as our critical value of T sub 0.10. Thank you for listening, math learners. I hope that you will answer all the activities that we have prepared for you. Keep safe and God bless always.